You don't have to be a scientist to love science and technology. Some little girl somewhere on Earth to become interested in science, and she becomes the next Einstein. The universe is, not only do we live in the universe, but we're part of that. So not just taking pretty pictures, it's understanding the universe around us so that we can be better, humans.
Like, let's just begin with your story. What I want to know is what space means to you, and how did was there like that moment when you knew that this is what you really love and this is what you would want to get into? I like to call
Mhm.
it like maybe you had a cosmic connect moment, or so if there is a cosmic connect moment that you had when you knew that this is what you want to pursue, if
Mhm.
you could talk about
Okay.
that and also what
Yeah.
space means to you.
Yes, of course. So as you know, I'm an astronomer, right? And so I study very deep space, things that are in very deep space. But I like all of astronomy that ranges from, the moon on out to the edges of the universe. And I think my my earliest my earliest moment of interest in the field was when I was very young. So as you say, the cosmic connection for me was when I was very young. I don't remember the exact time,
Yes.
but it must have been reading a book when I was, I don't know, 5 years old or something about astronomy, and I knew that was, for me, that was a very exciting and interesting field, and I knew that that's what I was wanting to become. And luckily, I've been fortunate enough to be able to follow that my entire life, and then go to school and become a professional astrophysicist, astronomer. And so, as I went through my elementary school and later, a little bit later, I didn't know what it meant to be an astronomer, but I knew that that was what I wanted to study. And then later, of course, in high school, at that point, then, having done research, I knew what I needed to do, focus on science and physics and mathematics in particular, and then with a very prescribed path at university. So a physics major as an undergraduate, and then going on to graduate school for astronomy, astrophysics. And that's very defined. Of course, I my goal was to become an academic astronomer, which I eventually did, although I'm not in academia anymore. And that's even more. That even has a more defined path, right? So you go through graduate school, you get into academia by doing a number of postdocs, and then eventually you get into a position that leads to a professorship. Certainly in the U.S.,
Right.
that's how it works. And so I went down that path. I was fortunate enough as an undergraduate to be able to do research in astronomy from very early in my undergraduate career, and that was fantastic. And it just further reinforced my goal of going into astronomy because I really loved the research.
Yeah.
Oh, during my education and then afterwards, I've studied a number of different areas of astronomy. I started out as an undergraduate working on topics related to stars, and then later in graduate school, I worked on clusters of galaxies and supermassive black holes and uh, things that are related to those topics. And yeah, so what does space mean for me? Well, of course, it's everything for me, right? Because astronomy is what I am. But but more pragmatically, I think space and closer to home, space travel and all the technology and science that goes into that, I think is very important for humans. not only do we explore, right? We've been exploring since the very beginning, and that's what we do. So space is just the next frontier, and we need to continue doing that, I think, and we're driven to do that. And we will, right? We'll go to the moon, and we'll go to Mars, and beyond, and maybe in the distant future we'll go to other planetary systems around other stars. That's a very difficult thing to do, but I'm sure we'll do that. So fundamentally we explore, but also this is a very important thing, not only for gaining an understanding, uh, building our understanding of science and technology, which it does, right? So as we develop technology to go to the moon and Mars, we're developing specific technology for that activity. But that the work that we do to develop that technology helps us in other areas on Earth, right? I always get asked, why do we waste time and money going to the moon or Mars or whatever? And my response is that we do because it's there, and that's how what we that's what it means to be human. But also we are developing our understanding of the laws of nature, the laws of physics. We're developing technology that's used for space travel, but also has uses on Earth. And so, yes, it's very expensive to explore space, but it's also providing a very strong foundation in science and technology for other things on Earth that range from medicine and medical technology to our cell phones and the technology that we use every day, our computers and whatnot. So it's really important to advance both our science and technology, but also just better our situation on Earth as humans.
Yeah, and I think that's an important question that you already answered, which I would have come to about, because that is something people ask and they still do wonder. Like, we do have people who are more driven and who are more excited, but people still sometimes ask, why are we spending so much out there? Just in line with that, since you have been an astronomer, you've studied the subject so much, what does it mean when you are, looking at those stars and trying to study them? Where does that come into the picture? How is that important? And that is what I would want the audience to know more about. Like, personally, I have been hooked to just always, having my head tilted towards the sky, looking at the stars, and I can never have enough of it. You can keep, looking at it, and it's not just about finding constellations and, star clusters, but it just also really grounds me, is what I feel like. One, I don't, a lot of times people say it makes you realize that you are this very tiny part of this entire universe, which is true. But at the same
Hmm.
time, every time I look up and I just realize how vast the universe is, I also feel grounded, and I also feel more responsible that how, a beautiful gift this life is. And being able to understand that, there are stars, there are so many other things happening in the universe. And I think that just makes me feel more valuable. It makes me feel more
Hmm.
value of this life. So, what does it mean to you to gaze at stars? And also, why do you think it's important that we look out at these stars and we study them?
Hmm. Yeah, so I mean, I think you said it right, that it helps us be grounded. But why is that? It's because we are part of the universe, right? So we're on a planet that's orbiting around a star that's orbiting in a galaxy that's in the universe. We're part of that universe, but also fundamentally, right? Every atom that's in our body has come from another part of the galaxy, and all the atoms, most of what is inside of us and on the Earth were formed deep inside stars that were much more massive than the sun. So we're integrally part of the universe, and I think that's fundamentally why we care. But compared to other sciences, right, astronomy is very accessible. You point out that You go outside at night and you can look up, right? Everybody can do that. And you don't need a telescope to see the stars and to see the moon and to see the sun. And so it's very accessible for everyone on Earth to be able to participate in astronomy. And I think that's unique among the sciences. And I think that's why there's lots and lots of interest in astronomy. Um, so, the universe is not only do we live in the universe, but we're part of that. So I think that's the very fundamental response to your question.
Yeah.
Now, more technically, let's say, right? I observe. My area of research is supermassive black holes, and that's neat. It's cool. Black holes are fantastic things, and they're very strange and bizarre. But what does that really matter for someone on Earth, right? It's an astronomical image that comes from the James Webb Space Telescope, for example, or the first image of a supermassive black hole from the Event Horizon Telescope of a couple of years ago. That's beautiful. It's awe-inspiring. It's awesome. But what does that mean? How does that impact the everyday life of someone in India or someone in the United States or someone anywhere on the earth, right? And the answer to that is that astronomy is a basic science. And by that, I mean that the discoveries that we make today may not have an impact on technology or humans immediately, but it will in the future. Why? Because even though I'm studying supermassive black holes that are distant and may not have a direct impact on our everyday life, I'm using laws of nature to study them, and I'm testing laws of nature by observing these objects. And so the basicness of astronomy means that we are developing a better understanding of the laws of physics and the laws of nature. We're discovering new laws of physics, and we're understanding how the universe works from the smallest levels to the largest levels. And that's important for astronomy, but it's also important for us as humans. And it's important for our technology. So I might my colleagues and I might be testing some laws of physics that we use the supermassive black hole and its environment to do the tests for us. And the information that we get, the understanding that we get, may have an impact in 50 years on developing new technology on Earth. And so that's what I mean by the basic science. We're understanding the universe so we have a better understanding for the basis of the technology that we will eventually develop as humans. And so that's fundamentally important. You can say, yeah, those astronomical pictures are pretty, but they don't help, with climate change or developing new types of wheat or whatever. They're not doing that today, but what they're doing is building an understanding of nature so that we can make better technology and applications through the science in the future. And so that's vitally important. If we don't do this basic scientific work, there won't be any applied scientific advances in the future. And again, we may not see what that benefit is immediately, but it will be there. So, Einstein, 100 years ago or more, thought when the theory of relativity came out, very few people understood it. It was very esoteric. How is this going to affect, me, the person in my everyday life? Well, no one knew. But you fast forward 100 years, and our modern world would not be possible without the theory of relativity. And so, this is what I mean by a basic science. There are things that we are learning today that will affect humans in 20, 30, 50, 100 years in ways that we can't possibly understand. And that's the importance of a science like astronomy. It's not just taking pretty pictures, it's understanding the universe around us so that we can be better, so we can
Right.
be better humans.
And again, this might be a little too basic, but just since because I'm targeting more students and just to expand on, because this is very interesting how you said that few years back, few decades back, we would not understand why theory of relativity is important, but now we are using it on our day-to-day basis. So if you could expand a little bit on that and just the basics of maybe theory of relativity and how we are able to use it now in our day-to-day life.
So, for a great example is the GPS, the global positioning satellites that allow. I'm pulling up my phone here, right? So I can determine my location to within a centimeter anywhere on Earth, and I can make a telephone call, and the cell phone system can locate where I am and then
Yeah,
transmit to a satellite. And all of that depends on um, the theory of relativity that is telling us that um, uh, the speed of the light travel time is different. If we're outside of a gravitating body, if compared to being on the surface of the Earth or up at where the satellites are. Time is affected by gravity, and so time clocks on the Earth are different than they are in the satellites. And so, if these GPS satellites or other similar systems aren't keeping track of that so-called time dilation, the effect of gravity on time, we they wouldn't be able to determine where we are, and therefore our smartphones wouldn't work. We wouldn't know where we are on the surface of the Earth, and we wouldn't be able to make telephone calls. So it's as simple as that. That it's impacting us very fundamentally in a way that, again, our modern technology would fail to function
absolutely.
properly.
And since we talked about images of James Webb, and I think that has been one of the most exciting things about this year and a great highlight of, because James Webb had been, ever since its inception, it's been getting delayed and there's been so much anticipation around it. Finally, it was out there, and I think everybody was just holding their breaths
Mm-hmm.
because it's so far away. We don't know what happens, how it goes. And then the results that we received have been, like, I think beyond imagination, at least for people like us who are not so much into astronomy. And you look at those pictures and you cannot but not get into an awe and just wonder about the universe out there. I've had friends who were absolutely not interested, but then I showed these pictures and it caught their attention, and they things have changed. Like, it is so surprising. They are a little different now when they look up at the sky. So, I mean, for you as an astronomer, what these pictures meant when you saw the images from Webb of the smacks, or yeah, any of these images.
They're spectacular, aren't they? And they're stunning for me as well, right? So I from the professional perspective, I didn't know exactly what they would look like, but I knew that they would be better and kind of how they would be better. And and that's the whole point of having this new, more advanced technology that we're using in the telescope to be able to get us bigger and better images than we've ever been able to do before. I mean, there's no point in sending something
Yeah.
that gives us the same information that we've already known about. And so that's what we do. Is the next generation observatories allow us to go deeper and to do better sorts of observations. And yeah, they're just spectacular, and they are allowing us to understand our old favorite objects, our old friends, in a better way. And they're also allowing us to observe new and unexpected objects, things that we kind of
Yeah.
guessed were there, um, things that we had no idea were there. And so that's allowing us to advance the field, the science. And I think that's really the most exciting thing, right? Is astronomy, we say, is still in discovery space. That is, that not
Yeah.
everything is known, and every day we make observations that give us new insight and to allow us to understand things better and to discover new things. And that's really exciting, and that's what keeps me excited about astronomy. That's what excited me originally about astronomy. There's stuff out
Oh,
there that we don't yet know, and Webb is just showing us that, and will
yes.
continue to show us
But
that.
while you were growing up, did you like have such things in mind, and did you ever think that this is where we would reach and these kind of images you'll be able to see?
No, probably not as a young kid, right? I mean, there were astronomical images and books and all sorts of things, documentaries. Uh, but probably at that age, I didn't realize that as we get new telescopes, we see
Yeah.
bigger and better things. But certainly, by the time I was 18 or 19 years old, that was pretty obvious. And again, it's that mystery of how does a star work? Number one, that's kind of mysterious, right? And then we think we understand that well, but learning that is fun. And then all those other astronomical objects that are less well known, or again, things that we discover that we never realized were out there. We need to try to figure out what they are and how they work and what it all means. And that's
Right.
that's fun. It's like solving a mystery. And there's new mysteries every day, and things like Webb and other observatories provide these observations of new astronomical objects that we had no
Right.
idea existed, until we've observed them. And this is, I mentioned early on that, or earlier, that technology development is very important, but maybe even more important is the young child who opens up their first book about astronomy at 10 years old, and they see fantastic images from James Webb Space Telescope and others, and that sparks their curiosity and interest and gets them to think about a career
Yeah.
in STEM, science and technology and engineering and math. And you know, they may not go into astronomy like I did, because long ago I was that little kid who was looking at an astronomy book. Maybe they don't go in astronomy, but it sparks their interest in science, and maybe they become a scientist or an engineer of a different sort. Or maybe they're just someone who doesn't go into science, but that early exposure has caused
Mhm.
them to be interested and educated in science. They don't have to be a scientist to You don't have to be a scientist to love science and technology. So I think that's very, very important. And people may disagree with me, but if the James Webb Space Telescope, for all its expanse and all it does, if all it really does is cause some little girl somewhere on Earth to become interested in science, and she becomes the next Einstein, right? There's that's incalculable how valuable that is. And so I think that's a very important aspect
Yeah.
for astronomy, because astronomy is so accessible to people. There's very few other sciences where you can say, "Hey, I invented a new chemical reaction," and that's exciting, but it doesn't really draw people's interest. But a new space telescope or a new observatory can make a fantastic observation of an astronomical object, and it's in the newspaper, and that people can look at that and be inspired, and I think that's
Absolutely. I
very,
think
very
that is
important.
very true. It does spark that curiosity, and I think that these images might just hook more people towards these subjects like you mentioned. And if not scientists, maybe they want to get into astrophotography, or they want to, like we've been now talking from STEM education, we are moving towards STEAM education, trying to also bring in arts. And I think that way we are just expanding the
Hmm.
horizon. As the universe itself is, it's expanding, and we're just expanding the amount of possibilities that we have with the subject as well.
Yes, absolutely. And that's a great point that you make about STEAM, right? So, inspiration of artists of all sorts. Uh, I think there's a connection between science and art, and there should be, and that's a great thing. So, inspiration, inspiring people to do things, and to your point, it doesn't have to be science. Uh, on the other hand, a well-educated public understanding maybe not the explicit nature of what a particular science does or what that particular astronomical observation means, but understanding how science works at a fundamental level
Important, yeah.
is vitally important, I think. And so, if these astronomical images that we see on our computer screens every day, if that helps more people understand how science is
Yeah.
done, I think that's a great thing
And
for society.
like one of the important things, when the first set of images came, we talked about stellar nursery, star births and star deaths. That has been really highlighted. How close are we to understanding that, how stars are formed, how stars die, and how does that help us in knowing the universe better, or how does that help us?
Sure. So I think we understand um, how stars form relatively well. There are little things that we're still learning, but it's it's a among all the things we can study in astronomy. Stars. The one of the nearest astronomical object to us is a star, and so that makes it slightly easier to understand. So how stars work and how they end their lives. Is a process that we understand fairly well. There are still some open questions, but I think they're just incremental improvements on our
Right,
understanding
right.
compared to some other areas that we don't understand, at all. Uh, this is important because obviously for us as humans, a star, the sun, provides all the energy that we use, and without that star, we would not exist. And so that's vitally important. Understanding, how life uh, works and exists on Earth, how our climate functions, to better position us to understand and maybe control the bad effects of climate change. This all comes out of
Right.
our understanding of stellar or stellar understanding of stellar astronomy plays a big role in this. But then also because we come from stars, and stars produce all of the elements that are heavier than hydrogen and helium. They're vitally important, and so studying them just allows us to understand how we were made, and the
Yeah.
earth and the planets and the sun came about, but also other stars and other planetary systems. Understanding stars help us understand
That's true.
those sorts of astronomical
Now,
objects as well.
to move on from like stars, you said we have a fairly better understanding of now. One of the closest astronomical objects to us is a star. From that, if we go to the one most mysterious thing that we have in the universe, black holes, and that is also your area of study. And it has again been an exciting time for that. Like we had our first image in 2019 when we had the first evidence of a black hole, and this year we had another image.
Yes.
So we are sort of progressing there as well. And for you personally, what do these images mean, and how exciting is it that we are getting these images, and how closer do you think we are getting to understanding black holes?
So theoretically, I think we understand black holes quite well, and again, the theory that underlies black holes came about from Einstein, right? So Einstein was a great thinker, and again, that theoretical foundation has been around
Yes, yeah.
for 100 years. So theoretically, we understand them really well. I think the important thing about these observations, by the way, that when I was a graduate student, if you asked me whether we'd be able to do this in my lifetime, I would have said no. And so, that was a great surprise that we're able to do this on that time scale. So I think the amazing thing about those observations, apart from the fact that we made them, because they're very difficult observations to make, um, the detail that we see at those black holes, both the black hole in the center of our galaxy and the one that's more distant in M87, those are the highest resolution images that humans have ever taken. So resolution is the smallness of objects that you can see on the sky. It's the equivalent of putting an orange on the surface of the moon and being able to see that from the Earth and determine that yes, it's an orange and I can see detail. So it's a fantastic technological feat to be able to make these observations. But beyond that, besides that, what the observations show us is that
Yeah.
the theory is correct. So the theory that we understand, that we think we understand quite
Yes.
well, needs to be tested against observations. And the observations that we've made to date, both of black holes indirectly before 2019, and then with these direct observations of the regions near the black holes, they are enabling us to confirm that the theories uh, do work as we expect them to. And I think that's a fantastic thing because, right, it doesn't just because we think we understand
Yeah.
how a theory works doesn't mean that it's correct. And we need to be able to test it against observations. And sometimes theories are wrong. And so, based on the observations, then we tweak them and change them and throw them out and start from scratch. But at least the theories that are fundamental to uh, strong gravity, such as around black holes, uh, as developed by Einstein, they are absolutely correct. And the observations are showing that
Right.
they are almost exactly right. So this is a good thing, right? Because again, these theories, relativity, as I said,
Yeah.
is important for all of our technology today, much of our technology today. And, if the observations of the black holes showed that something was wrong,
Good. Yeah.
then that wouldn't be so good. It would be interesting from a scientific perspective, but from the technology that relies on this
Yes.
information, it might be problematic. But we're not finding that. We're finding that those theories are good. So that's really the exciting thing as well.
Yeah.
Quite apart from
And
being able
and
to
it's
make
also
that
very
observation.
fascinating that without the, I'm sure he had something, but Einstein being able to put these theories out like hundreds of years ago, and now we are finding evidences to it, and it's so close to the theory. It's just something else.
Yes. Well, Einstein was a pretty smart guy, and I think that that's what it's about. But also, the universe works in a very logical way that we can understand, and we
Right.
understand some of it. We don't understand all of it, but we're building on that knowledge, and I think that's both a testament to human intellect, but also the
Right.
underlying principles of how the universe works. So these laws of nature that people like Einstein are thinking about in theory, and the laws of nature that astronomers and physicists and other scientists are studying, and and understanding more clearly every day. I think that's
Universe work.
it's just how.
So all the data that comes in from these images, from everything that we are collecting, and we have these images. Now we further study upon those data, and that you think helps us get ahead, understand better what happens with all the data that we've been collecting.
So astronomers who study these things will continue to analyze the images and take more data. I think one of the things that they'll be able to
Yes.
do is, and we're talking about the black holes here. So one of the things that they'll be able to do, at least for the black hole in our galaxy, is take videos. And so we'll be able to see motion of the gas around the black hole. And that will
Yeah.
be very interesting and very important because again, it'll confirm our understanding of black holes. So lots of work is still remains, and many more observations will be made. Also, we can't at the moment observe other
Yeah.
black holes other than the two that have already been observed, just because of the
Distances.
sizes of black holes and the distances. Uh, the next generation of instrumentation will allow us to observe more black holes, and obviously that's important. We might be looking at two very unusual ones that just happen to randomly fit in with what we expect. And if we observed all the other ones, we might find something different. I don't think that'll be the case, but it's obviously important to get more
Absolutely.
observations of different
Yeah.
objects. And that's what
And
will be coming
now,
into the
again,
future.
this is just to come back to the very basic understanding of if we want students to understand astrophysics and astronomy, how would you help them understand both? Like, they are somewhere aligned, and there are certain things that are common, they have a common ground, but there are also certain differences. So, if you could help us understand that.
Sure. I think
Okay.
they're more similar than different. Nowadays. So astrophysics is maybe more about incorporating theory and observation. Um, Maybe the astronomer who uses satellite observatories might be considered an astrophysicist, where an astronomer is more the traditional ground-based observatory, the
Right.
optical or radio observatories that are on the Earth. But the distinction is not very large nowadays. In the past, an astronomer who was mostly working with theory and models and simulations of astronomical objects might be considered an astrophysicist, whereas an astronomer would be one taking observations. 50 or 60 years ago, that might be the distinction. Nowadays, I have some colleagues who like to make a distinction, but many others who don't think there's much difference. And I would say that there's very little difference between the two. So you can use both of them: astronomer, astrophysicist,
Okay.
astronomy,
All
astrophysics.
right.
It's more or
And
less the
from
same
how
thing.
you were growing up to now, there's more awareness, there's more activities that are happening. There are more countries that are coming in. So space as an industry is also expanding. So how do you see the opportunities for students now who are growing up, or who are even in their early careers, or are doing graduation? How do you see the scope of opportunity for them when it comes to the space industry?
Yeah, so including astronomy, there's still lots to be done. Um, but in the broader space realm, right? We're at the beginning of a very large push to the for the commercialization of space. Now we've been saying this for the last 50 years, but I think we really are there. Not quite there yet, but we're getting there. So there's the traditional aerospace industry jobs, um, aerospace engineering jobs in industry of all sorts, space launch vehicles, spacecraft, satellites, all sorts of different satellites to do things, astronomical observatories, satellites that observe the Earth and help us understand the Earth better, spacecraft now for transporting humans to the near Earth environment to the moon, and then beyond. Robotic spacecraft going to Mars. So lots of engineering jobs, not only aerospace engineering, but electrical engineering and mechanical engineering. Uh, Lots of jobs
Yeah.
in policy. How do governments look at space? Should there be laws that help us explore and live in space? Um, there's there. How do we fund space exploration and space activities? So there's a big area, growing area of science and space policy that people might be interested in pursuing.
Yeah.
Uh, Science outreach is becoming more and more important. So communicating science uh, as a journalist, as a someone who translates between the scientist and the public, scientific discoveries
Yeah.
and many jobs of this sort in the science communication realm. So there's all sorts of things for someone who is interested in the topic, who may not want to be an engineer or a scientist, that they can
Right.
still uh,
Definitely.
contribute
Yes.
greatly to
And
this.
just to close on, I have these quick two, three questions, which are like a quick sort of a rapid
Okay.
fire, not really, but sort of. You mentioned about the books you used to read while growing up and how that also would have caught your interest. Do you have a favorite book or books?
So in general, or in this in
Both ways, but yeah,
science and
more maybe
technology
about in the
realm.
space realm, in the science and space realm. Yeah.
So lots of books. Like you can see a small collection behind me. I like books very much. Um, so it's really hard to put my finger on any one in particular. But
Yes.
I grew up with the books of Carl Sagan, and there are three or four or five of them. Contact is one. Broca's Brain is another by Carl Sagan, and these are excellent books. Lots of science fiction. So I love science fiction, and science fiction in book form I think is very important as a
Right.
instigator of interest, right? Because you can think beyond the confines of science, and that just makes it more interesting, I think. So I could name a few, but
Yeah.
just off the top of my head, Larry Niven's works were very important as I was growing up, and he has a number of series of very interesting science fiction books, including uh, uh, space space related topics that are kind of near to our
Yes.
technology, so space stations and things. Um, so your listeners might want to, if they're
Yeah.
not aware of
Yeah.
Larry Niven's
And
works,
do you
they might
also
want to
watch
look into
movies? Do you have any favorite movies, science fiction movies?
Yeah, again, all of them. So fundamentally, Star Trek and the original series in particular was very important for me. And so I mentioned, reading a book early on about astronomy. That was certainly the case. But then a little bit later, a few years later, Star Trek came on the scene for me, and yeah, Star Trek has been
Yes.
vitally important to my formation as a scientist. So all things Star Trek, Star Wars is very interesting. A very early science fiction film from the late 1950s is called Forbidden Planet, and I think that's one of the finest science fiction films out there. And so again, if you're not familiar with it, I would strongly recommend that you watch that. It has
All right.
very
I'll also make a
deep
note
and
of that. I
interesting
haven't
topics.
watched that one. But when you see these movies, are you like, you get excited, but like, I get usually very excited, but do you also get bothered if something is not really represented very well or if there's more of fiction?
So it sometimes, right? It depends on how bad the science is. If it's really bad, I might get bothered by it. But on the other
Yeah,
hand, right, these are science fiction, so they're not science fact. And I do like science fiction that is closer to science than, say, fantasy. But on the other hand, fantasy science fiction has its place as well, and
yeah,
and they're very entertaining. So, I mentioned Star Trek. Star Trek relies on technology that probably is impossible. It's certainly impossible for us today, and there are some questions whether, in fact, it's truly possible by the laws of nature. I won't say that it's not, but that's the point
yeah,
of science fiction. Science fiction pushes us beyond where we may be and we think is possible, and in fact may be into the realm of the impossible. It sometimes it bothers me, but most of the time it doesn't, because I think
yeah.
that's
I
the
think
the the,
sometimes
the
it's just very
fascinating part of the
fascinating
science
how
fiction.
those movies are inspired by things that some of the science facts, but sometimes they also end up showing things that further inspire science to explore and try. And that I think is very,
Yeah, yes, that's right.
yes, yes,
It's cyclical, right? So somebody might be uh, start on a path of science and technology, and then they
yes,
develop something that goes
yes.
into
And do you
the next
have any
generation of science
favorite
fiction. Absolutely.
personalities from the space industry, or like Carl Sagan or any author or anybody, people you looked up to?
I'm sorry. People that I've looked up to. I've had scientists in my life whom I've looked up to that you would not have heard of. I but on the more on the broader level, I think Carl Sagan has been inspirational to me. He showed me that outreach is important, and that it's it's important to get the word out, but it's
Right,
also important and
right.
possible for a scientist to do that, because he was a scientist, right? So I think
All right.
I think he was a great inspiration in that regard for me,
Yeah.
for
And do
the
you
outreach
have a
work that I do,
favorite
certainly.
mission? Like there are so many missions that have happened, but any particular favorite ones?
Well, James Webb is very interesting at the moment. Um, I worked with the Hubble Space Telescope, and that was very
Yes.
special, and the Chandra X-ray telescope, and I did a lot of work with that. In fact, I did very early work on the satellite itself before it was launched, and so that
Yeah,
was very
yeah,
special,
yeah.
and has a connection to India, as I'm sure you know. Uh, and then on my day-to-day job, I work
Yes.
with the radio observatories of the National Radio Astronomy Observatory in the United States, and
Mm.
the ALMA Observatory in Chile is very special. It's a fantastic instrument, and then
Yes.
our very large
Yes.
array in North
Amazing.
America
And do you
is a
also
is
have
a
a favorite
fantastic
image
instrument
from
as
the web
well.
images for now?
So the cluster in the first set of
Yes.
five images, the cluster of galaxies was really uh, strongly impactful for me, because I did
Yeah.
work with clusters of galaxies uh,
Right.
some decades ago, and so yes, that was a beautiful image. The star forming regions are fantastic, because you get that sense of the three
Yeah.
dimensions, and that's something that you don't normally get in astronomical images, because they're two-dimensional images. But the quality of Webb is such that, in the Carina Nebula, you could see into the bubbles of the star forming regions.
Nice.
That was really,
What plans
really
specific
amazing.
now do you have when it comes to work? What are you looking forward to? What are you excited about?
So the National Science Foundation, where I work, uh, has a new ground-based
Wow.
telescope that's under construction at the moment, and will be turning on in a couple of years. It's called the Rubin Observatory, and it's designed to look for astronomical objects that vary in brightness in relatively short time periods. So things that flash into existence and then become faint again. And it will survey the entire night
Oh,
sky visible from its location continuously, and so it will detect and discover many millions of these objects that many of them we've never observed before, and we don't know what they are. So I'm really excited to see the results from that.
yes,
And
yes.
so keep an eye open in a couple of years. It will be
That's very, very exciting,
starting
and
up
I
the
hope
Rubin
that sometime
Observatory.
in my life I'll also get to visit and, be there on ground at that observatory.
Yes, yes,
Yes.
that would be a
Thank you
nice
so
opportunity,
much, Joe.
and I
Like,
hope
I
you
feel like
can
I can
too.
keep talking to you, I can keep asking you questions, but I will limit myself for today. But thank you so much for taking out the time, for patiently like taking through all the questions and answering them,
You,
explaining them, and everything. Thank you so much.
well, thank you, and thank you for including me and for your interest.